Now we're going to finish the section working with the square root property. Notice that this part right here is already factored, but my question would be, is that a perfect square? I think it is, because we discussed how that would really be x minus 7 times x minus 7. So anything times itself is a perfect square. Is 36 a perfect square? Yes. Therefore, instead of FOILing it out, moving the 36 over to set it equal to 0, I am going to use the square root property. When I do the square root property, I just take the square root of the left-hand side, and I would get, x minus 7. And then I would take the square root of the right-hand side of the equal sign. Now, we need to do a little side note. What is the square root of 36? Remember, the square root is telling me what number times itself will get me back to here. Well, what number times itself will get me back to 36? 6 will, because 6 times 6 is 36. Is there another number that when I multiply it times itself, I would get back to 36? Sometimes kids say no, 6 times 6. But are you really sure that's the only one? What are your thoughts of negative 6? Is negative 6 times negative 6 equal to 36? It is. So when I take the square root of this, I get rid of the squared. When I take the square root of 36, it is the positive and negative 6. Okay, we are now able to solve. I would have x minus 7 equals positive 6. X minus 7 equals negative 6. I would add 7 to both sides on this and get 13. Add 7 to both sides and get 1. My roots would be 13 and 1. These are the roots that x intercepts, not an equal sign. Okay, there is another way to solve this one. We could FOIL this. If I were to do that, I would get x squared minus 7x plus 49. Combine the two center terms, and I would end at x squared minus 14x plus 49. And then I will set it equal, because the whole time it really equals 36. Okay. When we solve things, I've been saying before, you only can solve if it's set equal to 0. So I would subtract 36 from both sides. I would get x squared minus 14x plus 13 equals 0. Now I'm going to run through all the questions in my head. Can I make it simpler? No. Is it a perfect square trinomial? No way. 13 is not a perfect square. Therefore, in this case, I could look for two numbers that add to 14, but multiply to negative 14, but multiply to positive 13. Those are the two numbers most students kind of forget about. Negative 1 times negative 13. They get me positive 13. Negative 1 plus negative 13. So I would have x minus 1 times x minus 13 equals 0. Well, that should look familiar. I take the first, set it equal to 0, x would equal 1. I'll take the second, set it equal to 0, x would equal 13. So in this problem, we can use the square root property because that's a perfect square. I can not have to FOIL it out, or you can go with what you know. FOIL it out, set the problem equal to 0, solve for your roots. All right, that is a lot. Feel free to stop the video, rewind it, see what I said too fast, see what you missed. Sometimes hearing things more than once is really good. Okay, this is a perfect square. So I'm going to take the square root of both sides. That would give me x minus 8 equals the positive and negative 11, because 11 squared is 121. Negative 11 squared is 121. So x minus 8 equals 11. X minus 8 equals negative 11. Add 8 to both sides, x equals 19 as one root. Add 8 to both sides, x equals negative 3 is my second root. Again, we could do what we did over here on the side, FOIL, set it equal to 0, and we would end with the same sort of answer. All right, I'm going to challenge you. I know I have only done 2 of them, but this next one is pretty much not the same, so I'm not going to challenge you. I want to talk about it. My apologies. I didn't realize I gave you a 13. Good gracious. This is still a perfect square. I am going to use the square root property. So I am going to use the square root property here. Well, the square root of that we know is m minus 5. Now, 13 is not a perfect square. I would get some gigantic decimal. Instead, I'm going to say it equals the plus minus square root of 13, and I don't really care what the decimal point is. We can all work a calculator. I don't care. Then I would have m minus 5 equals the positive square root of 13. M minus 5 equals the negative square root of 13. Add 5, so m equals 5 plus the square root of 13. Add 5, m equals 5 minus the square root of 13. You may completely change that to decimals if you want. I am very content with this. I often will even write it as one answer, m equals 5 plus and minus the square root of 13. Wow, that's a lot. We left it under the radical sign because it's not a perfect square. So kind of pretend in your head it was the 6 from the first problem, and then we go from there. Okay. Ooh, we have choices. I could subtract 100 from both sides and factor it. Or I can ask myself a minute, is this a perfect square? Is this a perfect square? And the answer is yes. Is this 2 times the square root of 1 times the square root of 36? It is. 2 times 1 times 6 is 12. In factored form, the square of the A term, the square of the C term, sign in front of B. Squared still equals 100. I know 100 is a perfect square, so I decided to try this approach. Square root property, that would leave me with y plus 6 equals, the square root of 100 is 10, and the square root of 100 is negative 10. Remember, there's 2 answers. Therefore, one root would be 4. One root would be negative 16. Now, again, we could go back to things we have practiced And I could subtract 100 from both sides, and y squared plus 12y minus 64 equals 0, because we're used to solving things when they're set equal to 0. Can't make it simpler. A is a 1, so I'm going to find numbers that add to 12 but multiply to negative 64. All right, so I could have a positive 16 and a negative 4. Add those together, you get 12. Multiply those, you get negative 64. So y plus 16 times y minus 4 equals 0. Set each of those equal to 0. We would get a root of negative 16. We would get a root of 4. Take a minute, look at that. Again, there are two ways to solve this one. Square root property. Factor it out, set it equal to 0. All right, now we're on to a different one. 12 is not a perfect square, so I noticed that in my brain. Is this a perfect square trinomial? That's a perfect square. That's a perfect square. Is 18 2 times the square root of 1 times the square root of 81? It definitely is. Therefore, in factored form, I would have x square root of the a term, square root of the c term, sign in front of b would equal 12. Now I feel like I'm back to the original one that we did on the top of my current page. M minus 5 squared equals 13. So I'm going to take the square root of both sides. And I would have x plus 9 equals positive square root of 12. That is not a perfect square number. And x plus 9 equals negative square root of 12. Subtracting 9 from both sides, x equals negative 9 plus the square root of 12. Subtracting 9 from both sides, x equals negative 9 minus square root of 12. Those would be my two roots, whatever decimal number they are. If I chose to say, whoa, this whole square root property thing is a little too much for me, I am going to subtract 12 from both sides so that I set it equal to 0. All right, so I'm sorry, thought I had the number in my head, but I wanted to check. So then I would get x squared plus 18x plus 69 now equals 0. I need to think of two numbers that add to 18 but multiply to positive 69. So I'm going to make a little list of the factors I know. I could do 1 times that. 2 does not go in there. 3 times that would be 23. 4 does not go in there. 5 does not go in there. 6 won't go in there. 7. 8 does not go in there. 9 does not go in there. 10. I know 11 doesn't. 12 doesn't. 13 does not. 14. So these are the terms. I'm going to pause a minute. The factors of this that add to that. Back in the day, if that is what we were doing, we would have used prime. But allowing us to use radicals and decimals, prime is no longer an option. This is worth a try. Many of you are very fluent at this and can do this pretty fast, but We now know the square root property. We need to not use the word prime.